Mrs. Stanley here. Let's talk about transformations. This is just an overview of the different things that we can do to an expression or equation and how that affects the graph. So we'll just first read through this. Transformations affect the appearance of a parent function. There are two main types of transformations. So we've got rigid transformations. They change the position or orientation of a function. Translations and reflections are rigid transformations. Non-rigid transformations distort the shape of the function by changing its size. Dilations are non-rigid transformations. The rules for transformations are given below. It is important to memorize these rules. Yes, even next year when we go into, if you take AP Calculus or if you go to college and you take Calculus, you're going to need to think about graphs and what happens to them without being able to see it, without having to use a calculator or anything else. So this is important information that's going to prove to be helpful. So, translations, a shift up or down. We can remember if we do f of x and we subtract a k value, the graph will shift down, right? And you can see that's what happened here. The graph was at 0, 0, and it shifted down. And then if it's going to shift up, it's just the opposite, f of x plus k. So you can see this one went up, right? Okay, another one, a reflection would be a flip. If you're reflecting in the x-axis, you can see they've already drawn it for you. They have their original function here, and it's flipped over the x-axis. That's just negative f of x, okay? And then to reflect in the y-axis, that's f of negative x. So just thinking about where the negative is occurring. Negative f of x, f of negative x. Okay, again, this is not something that has to be completely clear right here. We're just filling this out and then we will use it to do some practice. Okay, so what about left and right translations? If we are going, we have this here like plus h inside the parentheses. So f of x plus h shifted the graph to the left. So that's this one. And then if we had f of x minus h, it comes this way. Notice the positives and negatives. When we're going down, it makes sense that we subtract k, and going up, we add k. For left and right, it's the opposite of what we would expect. It says plus h, that means we're going to the left. And that seems strange because it's like a negative direction. So just keep that in mind. If it's x minus h, it's going to the right. Now we can also look at dilations. Now remember, these would be the non-rigid transformations, because they're actually changing the shape of the graph. So vertical dilations, a compression. If we have a times f of x, so something multiplied by the function. Now keep in mind, this is if a, I'm sorry, that was supposed to be a 0. If 0 is less than, the absolute value of a is less than 1. Okay, so that is the restriction on it being a compression. And then the other way is that if a times f of x is a stretch, when the absolute value of a is greater than 1. And you might be thinking, well, what if it's negative? Well, if it's negative, we know what's going to happen. The negative is going to flip it. The compression or stretch is just going to be based on the a. The negative is going to be considered what makes it change directions with a reflection. And then we've got some horizontal dilations. The horizontal dilations, we have compression, the f of bx. Notice the b is inside, it's multiplying inside the parentheses, unlike the a, which was outside. So f of bx, if the absolute value of b is greater than 1. And then f of bx is a stretch when a, or b is between 0 and 1. So if 0 is less than the absolute value of b is less than 1. So notice these are just the opposites, compression and stretch. If the b is inside the parentheses, its opposite limits, the just, I cannot think of words, I'm so sorry. The restriction on the values are switched between the vertical dilations and horizontal dilations, okay? So coming down to the last part, the function will compress or stretch vertically by a factor of a. And then you can imagine in the other one, it's a little bit different though. The function will compress or stretch horizontally by a factor of 1 over b. And so we are going to do a lot of practice and get used to this. This was just filling it in so that you can reference this piece of paper to remind you until you've got it memorized. Definitely make it a goal to memorize as much of this information as possible.